Hi all, welcome to my YouTube channel. In this video, I am going to discuss the tree diagrams and conditional probability. Let's see what the tree diagram is. The tree diagrams. Actually, tree diagram is a visual representation of all possible outcomes of a random experiment. Suppose we flip a coin twice. The first time, the outcomes are either head or the tail. Then if we go beyond, again head or the tail, head or the tail. Let's write down what the possible outcomes are. Or sample space of the experiment. Sample space. If I denote it by a silent, the sample space is the first one, head and tail, tail and head and tail. How many outcomes are there? There altogether 4 outcomes. What is the probability of head? We know that it is 1/4. The probability of head and tail 1/4. The probability of tail and head again 1/4, and probability of tail and tail is 1/4. In general, we denote the probabilities on the branches of the tree diagram. Since it is a fair coin, the probability of getting head is half. Again the tail is half, or half. Okay, now the probability of head. How do we calculate? The other way is we have to multiply head and head. What is it? It is half times half. It is 1/4. We know that. The probability of head and tail again half times half. It is 1/4. Similarly, the other probabilities we can calculate in this way. Now we will consider an unbiased coin. Probability of getting head is 0.6, and then the probability of getting tail is 0.4. Okay, if I draw the tree diagram, the first time head or the tail. Since it is unbiased, 0.6 and 0.4 as an example. Again, if you go to the next level, the second step, head and the tail, 0.6 and 0.4. Head and the tail, 0.6 and 0.4. Now, how do we calculate the probability of head and head? The probability of head and head is, it is 0.6 times 0.6. What is it? 0.36. The probability of head and tail. The probability of head and tail is 0.6 times 0.4, 0.24. The probability of tail and head, 0.4 times 0.6, again 0.24. Then the probability of tail and tail is 0.4 times 0.4, 0.16. Now let's consider these two situations. What the unbiased coin and a biased coin. For unbiased coin, the total probability, the probability of head plus the probability of head tail plus the probability of tail head plus the probability of tail. If we add them together, what is this? They are equal to 1. When we consider unbiased coin, what is the total probability? Probability of head is 0.36. 0.24 plus 0.24 plus 0.16. The total probability is equal to 1. Now let's consider conditional probability. Conditional probability. Actually, the conditional probability is the probability of an event occurring given that another event has already occurred. Okay, let's consider our simple experiment. Flip a coin twice. The first time we know that either head or the tail. Again, the second time either head or the tail, head or the tail. If we consider the first branch of the tree diagram, the probability of head here, the given that the head, because head has already occurred. What is this one? The probability of the tail, given that head. The probability of head, this one. If we consider this branch, the probability of head given the tail. The probability of tail given tail, this branch. Okay. Now we will consider a simple experiment. The outcomes are A and B. The first time A and B. If I do it again, A and B, A and B. The first time and the second time. If we consider this, the particular branch, this one, the probability of B here given A. Because the probability of B, we have to calculate the probability of B given A. However, we know that this one is the probability of A. If we consider the both A and B, which represent the probability of A and B. Actually, the probability of A and B is equal to the probability of A times the probability of B given A. We can write this one as the probability of B given A is equal to the probability of A intersection B over the probability of A. We can use this one as a formula, or the probability of A times the probability of B given A is equal to the probability of A intersection B. This is called the multiplication rule of the probability. Thanks for watching my video. In my next video, I'll be demonstrating how to use the tree diagrams and conditional probability for application questions. Thank you.